Geometry kids, hello. This is the chilly Friday morning, first Friday in April for me here, so I'm excited to see when we get to this, and when you're listening to this, hopefully it's a lot warmer than it is this morning. 10.6, we got two sections left in Chapter 10. This one I thought would be pretty straightforward, then I started looking at it, and there's some algebra review we have to do with it as well. So we're going to cover that in this video. In addition to what we do with these circles. And I think the algebra is going to be the challenging part with this, and not so much how to make the formulas. But 10.6 deals with segment relationships, 10.5 was angle relationships. So these are dealing with chords, we're going to have secants, and we're going to also have tangent lines. So chords, secants, and tangent lines. Remember that chords go through the circle and they stop. Secants continue on through the circle, and tangents just intersect, they touch at one point. Okay. So the main thing with chords, and we're going to go through these formulas and I'll go back and review the some of the algebra that you need to know. Okay, if you have two chords that intersect here, okay, they are just proportional to the length. So if I'm looking for this segment here, F, A to F, and that's X, okay, DC is broken up into a 9 and an 8. So if I take 9 times 8, that has to equal, 9 times 8 has to equal 18 times X. So what you do is you multiply, this is, sorry, page 304. You multiply the parts of each chord, and then you set the two chords equal to each other. So I'm going to take 9 times 8, and that has to equal 18 times X. Okay, so 9 times 8 is 72. So 72 equals 18x. 72 divided by 18 is 4, so x would equal 4. So that segment right there would be 4. So multiply the two parts of each chord, 9 times 8 equals 18 times x, and then you can solve. Okay, and that's what this is going through here, segments of a chord's theorem. If you take EA times EB, and that equals EC times ED. So that's basically what we just wrote down on the other page. Multiply the two parts together. So we get two chords. Let's say this is 3, this is 8. Let's make this one 2 and this one's X. So here are your two chords. 3 times 8 has to equal 2 times X. So 24 equals 2X, so X has to equal 12. So this one's 12. Okay? So that's chords. The next one, you only really have two more, and there's only 4 examples in the student journal. I'm doing you some more, and I'm going to give some straight from the assignment as well, so make sure you pay attention to that. That will see who is actually watching these videos and paying attention, because there will be some answers for the assignment. There's some tricky questions in there. Okay, segments you need to know, names of them. So if you have a secant, remember this this line right here, that is referred to as a secant segment. Okay, it goes through the circle and it extends past the circle. So this from P to R, P to R, that is a secant segment. The external segment is PQ. Q to R, that would be your chord. And then you have your tangent segment, which is P to S, okay, and all those are written down there. PS is a tangent segment because it intersects at point S right here. Remember, if you'd have a radius, that would form a 90-degree angle with any tangent line, radiuses and tangent lines. External segment is on the outside, the chord is on the inside, and the external plus chord is going to give you the secant segment. Okay. So how that works with if you have two secants, you take the EA, that is the external, you take the external segment times the secant segment. So EA times EB, external times secant, has to equal the external times the secant. So EA times EB equals EC times ED. So if we put some numbers to this, let's say this is 10, this is 2, this is 5, not drawn to scale, and this is X. How that works with this, and this is where the algebra is going to come into play a little bit more, is I have to take 10, not 10 times 2, I have to take 10 times this whole length. Okay, so this is 10 times 10 plus 2. And that has to equal 5 times the whole length, 5 plus x. So this is 10 times 12 has to equal 5 times 5 plus x. You need the secant segment on there, and they're not giving it to us right away. You don't take the outside times the inside. You take the outside times the total length. Okay, so remember that, outside times the total length. So 120 equals 25 plus 5x. So 95 equals 5x. So in this case, x would equal 19. So of course, not drawn to scale at all. Okay, so that's two secants. Segments of secants and tangents. So I have a tangent, and then I have a secant. The secant stays the same rule. Okay, we have an external times the secant. Okay, and here all you have is a tangent. That's kind of like an external segment. You just square it. So tangent squared. This is not the trig tangent. This is just the object tangent. So tangent squared equals external times secant. So we have an external, we have a secant right there. Let's say this is x over here. We don't know what that one is, but we do know this is 9 and this is, let's say, hang on. Let's say this is 5 and this is 4. Okay, so we have a circle. Here's our tangent segment x. We don't know how long that is. We know my secant has parts 5 and parts 4. So I have to take the tangent and square it, and that has to equal the external, which is 5, times the secant, which is the total length, 5 plus 4. So that's going to be 9. So x squared equals 5 times 9. So x squared equals 45. X is going to be the square root of 45. So if you have an x squared, to cancel off the x squared, you square root both sides. Square root of 45, if you break it down, that's 9 and 5. That's going to be a pair of 3. So that's either 3 root 5 if they want the exact answer. I think more than likely they will want an approximate. All of these will be exact. You won't have approximate yet. So the square root of 45, 3 root 5, it's about 6.7. Okay, so that's the only rules. Okay, and so the geometry part of this is not that hard. Tangent and secant, tangent squared times x equals external times secant. Two secants, external times secant equals external times secant. And the chord, this times that equals this times that. So the two parts equal each other. Now for some of the algebra. Okay. So when we look at number 1, we're going to set it up and then I'll show you what we need to review here. It's a chord, so I have to take x times x plus 1 equals 6 times 5. So x times x plus 1 equals 6 times 5. The two parts equal each other. So when I distribute, I get x squared plus x equals 30. We have an x squared. We have a quadratic. And in order to solve a quadratic, we need to be able to factor. Okay, Algebra 2, we did this quite a bit. It should come back pretty quick. Algebra 1, we probably did it about a year ago and just did a very minimal of it. So that's why I want to go over it again with you. Make sure you're paying attention. Okay, so solving this, remember when we're factoring, it is the reverse of the foiling or the double distributing. So if I have x plus 4 times x plus 3, how I multiplied that is I double distributed. Okay, so I had to take x times x plus 3 plus 4 times x plus 3. So the x had to be multiplied to both of these, the 4 had to be multiplied by both of these. And then we combine like terms. X squared plus 3x plus 4x plus 12. Combine like terms. X squared plus 7x plus 12. Okay, that is multiplying. That is FOILing when you multiply like this. Factoring is going this way. Factoring is when you start with this and you want to end up with this. Because if you want this to equal 0, this is where you get your zeros. So where does x plus 4 equal 0? So you'd say, okay, x equals negative 4, that would give me a 0. Where does x plus 3 equal 0? So x plus 4, where does x plus 4 equal 0? Where does x plus 3 equal 0? And that would be x equals negative 3. Okay, those would be the answers to that equation. So when we factor, we're gonna have something like this, x squared plus 7x plus 12. And all of them that you can do today, I'm going to give you the shortest cut I can. We want to know where this equals 0. I might give you 2 ways to do it. I think you'll like the second way. If there's a 1 in front, if there is a 1 in front of the x squared, what you need to do is find 2 numbers that multiply to the last number and add to the middle number. So if there is a 1 in front of the x squared, this was the model. We need to find 2 numbers that multiply to the 12 and add to the 7. Okay? So find 2 numbers that multiply to the last number and add to the middle number. So the 2 numbers that multiply, they have to multiply to 12, they have to add to 7. So what multiplies to 12? Well, that could be 1 and 12, that adds to 13, not it. It could be 2 and 6, that adds to 8, that's not it. It could be 3 and 4, that adds to 7. Those are our 2 numbers. Okay, those are our 2 what we call the factors. So it would factor into x plus 3, the 3 went there, times x plus 4, which we know are the 2 parts that multiply to our original question here. Now remember, we want to set equal to zeros. The zeros are the opposite numbers of the factors. The zeros are the opposite numbers of the factors. So if the factors are 3 and 4, your zeros would be negative 3 and negative 4, opposites. Okay? So this gives you the factors. This gives you the opposite of the factors. Those would be your answers. Now in our situation, for geometry, we only need positive answers. So notice we got 2 answers here. This is not indicative of what our situation will be. We only want positive answers because we're dealing with a length. We're not going to have negative lengths. Okay? So another way to look at this is a graph. So good old Desmos. And if you graph it, you're looking for your x-intercepts. So x squared plus 7x plus 12. So what's pretty cool is look at where your x-intercepts are, negative 3 and negative 4. Okay, those are your zeros. Those are your solutions. That's where the function equals 0. So this is a function right here. This is where it's equaling 0. Okay, so negative 3 and negative 4. So let's go back and look at our situation here. I had x squared plus x equals 30. I'm going to minus the 30 over, set equal to 0. So minus 30. So x squared plus x minus 30 equals 0. So I have a 1 in front of the x squared. So I want to find 2 numbers that multiply to negative 30, and they have to add to positive 1. So 2 numbers that multiply to negative 30 add to positive 1. So if they're multiplying to a negative, it has to be 1 negative and 1 positive. So if I go negative 1 and 30, well, that adds to 29. Doesn't work. Negative 2 and 15, that adds to 13. Doesn't work. Negative 3 and 10, some of you are probably already there, that adds to 7. Doesn't work. Negative 5 and 6, that adds to 1. Negative 5 and 6. So these are the factors. So when you break it into the factors, you'd go x minus 5, because it's a negative 5, times x plus 6 equals 0. And now imagine setting each of these equal to 0. So if you have x minus 5 equals 0, x would equal 5. And if you have x plus 6 equals 0, you minus the 6 over, x would equal negative 6. Well, we don't want negatives here for geometry. We're going to go with this value for x. So x would be 5. So x equals 5 in this case. That'd be 5 and 6. That'd be 5 and 6. They bisect each other, actually. Or not bisect, but the congruent segments there. Okay? If we look at the graph of this, if I have x squared, oops, there we go, x squared, not x to the x squared plus x minus 30, zoom out, you notice my two x-intercepts are right there at negative 6 and at positive 5. A little bit bolder for you. So negative 6, positive 5, there are my x-intercepts. So you take the positive answer, 5. Okay, that'd probably be the easiest way for you to get those answers. Okay, so number 2, chords again. So the two parts equal each other. 10 times 7x equals 15 times 5x minus 2. So 10 times 7x is 70x equals, distribute to both, 15 times 5, 75x minus 30. Okay, there's no x squareds here. This is just a linear function now. So this one is linear. We want to just solve for x. So I'm going to minus the 70x. Now let's just bring the 75x over here. We'll work with negatives. So minusing 75x. 70 minus 75 is negative 5. Negative 5x equals negative 30. Don't forget that negative sign. So x equals 6. Okay, you can plug it in and check it. Number 3, this bottom one is a secant line because you have two parts. It looks like it might be a tangent, but there is a secant line here. So remember, you have to take the external times the entire length. So this entire length is x plus 3 plus 2. So this entire length is x plus 5. This entire length would be x plus 2, 1 plus it, 1 plus x plus 2, so that'd be x plus 3. So you want to take external times secant. External times secant. There's a rule here for secants. We're following this one. We'll take the external times secant. So I'm going to take 2 times x plus 5, and that has to equal external x plus 2 times the total length, which is x plus 3. Okay, this is the double distribute. This is, or foiling. So 2x plus 10, we have to take the x times both of these. So we have to take x times x plus 3 plus 2 times x plus 3. So I get 2x plus 10 equals x squared plus 3x plus 2x plus 6. Combine like terms. So 2x plus 10 equals x squared plus 5x plus 6. You see the x squared? That means we need to get everything on the right side. So I'm going to minus the 2x and minus the 10. So 0 equals x squared plus 3x minus 4. Okay. Now you're ready for the MOS. So what multiplies to negative 4 and what adds to 3? So multiplying to negative 4, adding to 3, that's going to have to be negative 1 and 4. That would add to 3. So this factors into x minus 1 times x plus 4 equals 0. So you set each one equal to 0. So x minus 1 equals 0. So if you add the 1 over, you get x equals 1. X plus 4 equals 0. You add that, subtract that over, you get x equals negative 4. Remember, we want the positive answer. So x equals 1 in that case. All that work for number 1. Woohoo! Yay, go us. Okay. So here, this is a tangent. And then we have a secant line. So again, we need the total length. If this is x minus 1 and this is 5, the total length would be x minus 1 plus 5, which would be x plus 4. So our work here, we have to take x plus 1 tangent squared equals external x minus 1 times the total length x plus 4. Okay, I'm going to have to bring this down to give me some more room. X plus 1 squared. If you're squaring x plus 1, you have to take x plus 1 times x plus 1. Okay, x plus 1 squared, x plus 1 times x plus 1. This one you have to double distribute, so x times x plus 4 minus 1 times x plus 4. This one also double distribute, so x times x plus 1 times x, plus 1 plus 1 times x plus 1. So that's x squared plus 1x plus 1x plus 1 equals x squared plus 4x minus 4. Distribute that negative 1 through there. So x squared plus 2x plus 1 equals x squared plus 3x minus 4. Oh, we had a favor here. Okay, look at this. We got the x squareds, but look at what happens if you subtract x squared from both sides. They are gone. So now I'm going to minus the 2x over here. I get 1 equals x minus 4. Add the 4 over, x equals 5. Woo! You didn't have to factor. So x equals 5. So your tangent would be 6, and this part right here would be 4. So you can check it. Does 6 squared equal 4 times 9? 4 times the total length, and yes, 36 equals 36. There we go. Okay, I'm going to do a few more examples that will follow along. Questions 3, 6, 7, and 11 were some that I pinpointed. Some of these are, I think 7 and 11 are exact questions, so if you've watched this far, it'll help you out. I won't completely finish it for you, but I'll get quite a bit of it. Okay, so number 3, we have chords, so x times x plus 5 has to equal 4 times 6. So x squared plus 5x has to equal 24. Minus that over, x squared plus 5x minus 24 equals 0. So we need to multiply to negative 24. We have to add to 5. Okay, so you can go through those, 1 and 24, 2 and 12, 3 and 8, negative 3, and positive 8. Those add to 5. So that factors into x minus 3 times x plus 8 equals 0. So your zeros, remember me saying, your zeros are the opposites of your factors in this case. So your zeros would be x equals 3 or x equals negative 8. Go with the positive one. So that'd be your answer. Okay. 2 secants. Again, this one you need the total length, so that's x plus 3. And this total length is 4. So we have 2 times 4 equals x times x plus 3. So 8 equals x squared plus 3x. And I made this one a bad example. Well, let's finish it in this case. So we minus the 8. So 0 equals x squared plus 3x minus 8. So if you're solving this, you're looking for what multiplies to negative 8 and adds to 3. You're going to look for a long time. In this case, those who are in Algebra 2, you could use quadratic formula to solve this. But multiplying to negative 8, that's either negative 1 and 8, which adds to 7, or negative 2 and 4, which adds to 2. So it doesn't work. So that's where graphing could come in handy. You will not have one like this. All of yours should factor. They'll be nice clean numbers. So x squared, I miscalculated some of my numbers. Minus, not 30, minus 8. So we could use this to say, okay, we don't want the negative, we want the positive. So x is about 1.702, or 1.7. That looks like two approximate symbols, doesn't it? That's an x is approximately 1.702. Okay, the graph is nice. Okay if you use it. Okay, 7, 2 more examples. Total length, need that, so that would be 9. Here, total length This is, you have to take x minus 2 and add x plus 4. That gives you 2x plus 2. So from end to end, it is 2x plus 2. So we're going to take the external times the total equals the external times the total. So 36 equals x times 2x plus 2 minus 2 times 2x plus 2. So 36 equals 2x squared. That's a little different. Now we have a 2x squared plus 2x minus 4x minus 4. So combine those together. Let's minus the 36 over. We get 0 equals 2x squared minus 2x minus 40. So this one's different in that we have a 2 in front. So we can't immediately take our shortcut and find our answers. The graph will work. Yay for graphing. But you also notice that each of these are divisible by 2. So you can divide everything by 2. 2, 2, 2. And you get 0 equals x squared minus 1x minus 20. So what multiplies to negative 20 and adds to negative 1? That'd be negative 5 and 4. So 5 and negative 4 are your answers. So 5 would be the one you want. This factors into x minus 5 times x plus 4. You want your positive answer, so x would equal 5. Okay? And we did one with number similar to number 11. That was like number 4 on the student journal. Make sure when you square your tangent, when you take x plus 4 and square it, that should equal x times x plus 12, because the total here is x plus 12. Make sure when you square that, you're taking x plus 4 times x plus 4 and double distributing that. Okay, so I'm not going to work that any closer to you for you, but I want you to make sure you are taking x plus 4 twice, double distribute that. So x times x plus 4 times x plus 4. Okay. All right, questions on this? If you have some, that's okay. I understand. On all of this, of course. You know that. So I'm here for you. Let me know what I can do to help. Please stay active every day, doing a little bit. That's going to make it go through, make you progress correctly through the assignments. So I hope you're doing well. Whenever you get to watching this, it could be a couple weeks from now, and maybe we'll be out of the stay-at-home and we can get out and move around a little bit more. That'd be a good thing. So stay hopeful, stay encouraging, reach out to other people and just say, how are you doing? What can I do? What can I think about? Pray for you on different things, and try not to be isolated in just your own little world, but reach out to other people as well. So talk to you later.